The headstock on this digger, on this excavator breaker, won't fit my excavator. It's just a little bit too narrow here. I bought this with some buckets, and the buckets all fit, but this doesn't. So we're going to need to increase the gap in here, so I need to take it off. Something like this, can't, so I don't have to put it on the floor. So we're going to bolt it up to this tool. So it's we're going to have a so it's all first. That's a simple thing. We're going to here. Okay. So we've now got the headstock mounted on the milling machine. We've got a DTI on this plate. I've measured it and got it as flat as we need it. There's a curve in the plate around 2mm, but end to end it's fairly straight. It's looking like this headstock was originally on a different machine, and somebody's cut these plates off, the original plates off, and welded some new plates on, and they've made the plates themselves, and it's not quite square. I've taken a few measurements and it's a little bit out here and there. Maybe their setup wasn't, if they did it in the field on the machine, possibly, with some spacers in here, and the machine had some wear in it, so it's been built to those tolerances. Of course my machine's also got wear in it, but we're getting roughly around 125 to 128 gap between these bends. So my dipper arm, for the dipper arm, it's got about 125mm gap, and I need 135, so I need to take 10mm out of this. So what I'm going to do, I'm going to put a milling cutter in the lathe, and I'm just going to sweep it across all the pins and take approximately 5mm off each side. Now we've got a tolerance here of around 5mm. It wouldn't matter if it was 10mm. It's not a precision job. We just need a big enough gap in this to get it onto my machine. So yeah, we'll go from there. So here we are with a cutter. Let's try and get some light on this. Lighting isn't the best in this workshop. So we've got the cutter in the milling machine, and we're going to advance the tool until we touch off, and then I'm going to set 0 on the DRO, which is up there, and remove approximately 5mm. I shall do it on 600 RPM spindle speed, and I'm going to have a fairly slow table speed of, what do I get? We'll try 6 inches per minute. So first of all, we just want to touch off. Now, we're not expecting this to be square. In fact, we know it's not square. Okay, so I'm going to set my 0 on my y-axis, and I'm going to advance that by, let's put this in millimeters. We'll take off let's take off 1 millimeter first, because we don't know how it's going to get to this end. Some of you will notice that I am climb milling. Probably not the best idea, but we'll see how it goes. That is taking a lot off there. Okay, I'm going to put the DRO back on this plate and see what's happening, because that's taken a lot off there. I would expect the plate to move away, but even so, let's have a look. We'll just put it down here. No, we're still good. That really was out. Okay, well, we'll move up here and touch off at this end. We'll re-zero. We'll take 1 millimeter off. And we'll do conventional milling this time. Be a little bit more stable. I'll take another millimeter. We just check the other end. That's all clear. Take another millimetre. Okay, and we'll come across to the other side now. Now, you might be able to hear that it's chattering. I'm not really worried about that. For what this is doing, we're just trying to make clearance. Otherwise, I would be bracing it and trying other sorts of things. Excuse my head for a minute. Right, we've cleaned up across all the faces. Now we'll have a look and see what measurement we've actually got. At least it'll be square now when it's on the machine. Excuse my head a minute. Yeah, that all seems okay to me. Now, we'll see what gap we've got. 127.8. 127.8 and I want 135, so I want 7.2 millimeters. So I'm going to zero my DRO and I'm going to cut this side again until I get 3.1 millimeters. So advance that again by a millimeter, 40 thou roughly. So we'll just do a sanity check, make sure we are where we think we are, and measure the gap we've got. Put some more light on. A little better. Uh, 131.25. $131.5. So I want 3.5. We'll take 3.5 off the other side, 3.6, and see where that gets us. So there we are. We should now have our 135. $135.08 millimeters. That is good enough for me. Certainly for this application, because we could go another 5 and we'd still be fine. But there's not a lot of meat left on these with them being twisted. So we're going to leave it there. So we'll take it off the mill now. So there we are. I've milled that quite a bit as well. There's still plenty of meat on it. There's enough clearance so it doesn't rub. So we should be good. Just do a little bit of deburring. That just gets rid of that little burr. Although on something like an excavator it wouldn't be there very long. Right, thing to do now is to try it on the machine and see where we are. But that's it. At least they're parallel now, which is something. So we'll see you over at the machine. Two hoses, one of them had completely broken, so I thought, I'll just get two hoses from the local supply. 100 quid. You know, they say inflation is 8%. I'm not quite sure where they get that from. Was it 8% where I spend it? Some things are more like 100%. Literally. I went for a bottle of welding gas a couple of days ago, and normally it's £23 for an exchange 10 litre bottle, 6.4 kilograms. I got an account with them, so they just send me an invoice later. So I just picked it up. Well, no, invoice comes later on. 50 quid. How does £23 to £50 or £49.97 relate to an 8% increase in inflation? I'm not sure who's doing the maths, but it's not the same as my maths.